This is video number 3 for Math 107 for homework for Chapter 7. Now we're to sequences and series. What's the difference? Sequence is an ordered list. A series is the sum of a sequence. Unfortunately, they both start with S. So if you are a glancer, not a careful reader, then you can kind of get mixed up there. Sequence is the ordered list. Series is the sum. Okay, now this is a sequence. We need to, in 14, define that recursively. First thing, you've got to figure out what's going on in the sequence. The sequence is starting at 1, and if you look, there's a common difference between all of these. It's like you add 4 to the previous one, and then you get the next number. This is an arithmetic sequence. And there's really two ways to define this sequence. There's the regular longhand way that works for all of them. Let's use A for the terms of this sequence. So let's say the first one, A1, and we'll say that's 1, which is what it is, A1. Okay. Now you have to say what happens to the next one. Next means n is your counter. Next plus 1, that means the next one is the previous one, which we'll just say is A to the n. You see, n plus 1. The subscript gives its place in the sequence. Okay, this is one way to write it. If you're having trouble with these counters, what can I say? They have a little arithmetic in them. If I wrote them down like this, here's my sequence. A, 1, 2, 3. You see, I use A, meaning a term of the sequence, and the subscript is its place in the sequence. This is the fourth term. In this sequence, A to the fourth would be 13. Now, if you want to do this just in terms, of course, these numbers are going to go on for quite a ways, so you want to do it symbolically. If this is the nth term, the next term is the n plus 1 term. Just like if n is 3, you add 1 to get to the next term, which is 4, and that's what's meant here. That's kind of well, I know it might be a new concept to some of you. All right. Now, because this is an arithmetic sequence, there is another way to write it, which is probably even more obscure than this. So here's the second way, which is only because it's an arithmetic sequence that I can write it in a shorthand way. I can say that the n plus 1 term equals 1 plus, I should have started it the other way. Okay, let me start it the other way. Let's say the next term in this, or the term in the sequence equals 1 plus 4 times n minus 1. So let's see what happens. Let's let n equal 1. If n equals 1, then we say A1 equals 1 plus 4 times 1 minus 1, which is 0, so it equals 1. That's true. The first term is 1. Let's let n equal 2. So then A2 is 1 plus 4 times 2 minus 1, which is 1, so it's 5. See, this is working out. N equals 3. I'll do this and stop. A3 is 1 plus 4, but now n minus 1 is 2, so that's 8. Now I get 9. You see, that's working out. Okay, because it's arithmetic, I can kind of wrap these two lines together, but in general, you have to specify a starting point and then specify the pattern. In this class, the two sequences we study the most are arithmetic sequences and geometric sequences. So what does an arithmetic sequence look like? Okay, you should kind of know this. A to the n equals the first one plus n minus 1 times the common difference d. So d is a common difference. In the previous case, it was 4. All right. And here in the previous case, A1 was 1. So you do that and then make up your own arithmetic sequence. Write out the first 4 numbers and write its definition. Now for a geometric sequence, as you look at the terms, they're all multiplied by some number. For example, if I started with 3, before. Okay. Instead of having a common difference, there's a common ratio. If I divide these two numbers, I get 2. If I divide the 6 and 12, I get 2. The 12 and 24, I get 2. This is a geometric sequence because each number is multiplied. The previous number is multiplied by the common ratio to get the next number in the sequence. This is your geometric sequence. How do you write it? Okay. For arithmetic, you have the common difference. For geometric, you have a common ratio, and it's a multiplier. So it looks like this. A to the n equals the first number, r to the n minus 1. Okay. And I should have written that up here, I'm sorry. Greater than or equal to 1. Right? There's your ratio. There's your geometric sequence. Now you're supposed to define one and then write its recursive definition. For example, what would this one be? A to the n. The first one is 3 times, and the common ratio is 2 to the n minus 1. Remember that an exponent only goes to the number right before it. In 17 through 19, you just need to find out, you just need to identify it. It's going to be either an arithmetic sequence, in which there's a common difference between the terms, or a geometric sequence in which there's a common ratio between the terms. Now we're talking about the series, the sum over a sequence. That means if your sequence looked like this, A1, A2, A3, on and on, the sum for the first 4 terms would be, just add them up, A1, A2, A3, and A4. For the arithmetic and the geometric sequences, or series, well, for the arithmetic and geometric sequences, the related series has a special formula that's very compact. Otherwise, you just have to add a whole bunch of terms together, and that can be error prone. Okay, so for these, I'm going to go ahead and derive it again because I think helping to remember how it's derived will help you with the formula. Here was the supposed Gauss idea for adding up the terms. And this is an arithmetic sequence, so I'll just give you an example of it. Let's say I have an arithmetic sequence that looks like this: 2, 5, 8, 11. Okay, what's the common difference between all these terms? The common difference is 3. Okay, and this is an arithmetic sequence. Say I want to add, I'll just say the first 4 terms. Okay, 2 plus 5 plus 8 plus 11. So this is a sum over the first 5 terms. Okay, this is also the sum, or 4 terms. This is also the sum over the first 4 terms. 11, 8, 5, and 2 would give you the same answer, right? Okay, you can add them forwards, or you could add them backwards. Now let's add these two together. Over here I'll have 2 sums, right, if I add them together. But look what happens when I add them together. I get 13, 13, 13, and 13. Interesting. So the sum would be all of these 4 13s divided by 2. But I could abbreviate this as 4 times 13 divided by 2. Alright. And the 4, actually this should have been a 4 down here. The 4 came from there. Okay, but where did I get the 13? Well, I could have added any one of these combinations, the first and the last and the first, the next to the last and the next to the first, or you see, but the easiest ones to pick out of here would be the first one, the 2, and the 11 divided by 2. So now I want to write that formula in general. The sum over the n terms is n times the first that you want to add and the last term of the sequence that you want to add. So the first term and the 4th term, and then divide by 2. Very handy. N, see the n came from here. Then I look at the first one and the nth term and divide by 2. And you can figure out what the n terms is because you know the common difference.